we hope that any of our friends or relative that involved in a flood, so hope they are in a safe area, safe. Right. Also, a few of our friends involved in the flood. So I hope them are in a safe and better condition. Right. Okay, we will continue our lectures in this non-permanent joint. Okay, right. I would like to highlight something regarding last week. Okay, few students uh, send very good, nice notes and lectures. Write down something. Okay. Okay. So this is one of the your friends' feedbacks. Your friends' notes on author. Okay. Very nice. Uh, Notes. Okay. Only okay. For example, this one. I hope that okay. I'm quite sure that I think it's, she knows these her notes. Only that units, you make sure that you write down a proper unit for this one, KB. Don't put 2.6 inch. This is not correct actually. Okay. So a few answers. Okay, this one 2.6, and then okay, another answers 2.2, 2.6, 2.2 mega. I'm not sure the units, maybe incomplete. The third one, okay, 3.2, 3.2 mega pound inch. Okay, should be if you okay, okay, right, KB, this one. Okay, so units, okay, unit pound inch, pound inch. So okay, the third students able to put a right unit, pound inch, okay, mega pound inch. Okay, I'm not sure. Yeah, they are exactly correct answer. 3.2, 2.2, 2.6. Sure. Right. The important that the important is you using the correct units. Okay. Right. you still remember that we work on example. Okay. So we still work with the same example. Okay. Okay. We learn about non-permanent joints, okay, which is involve bolt and nut. Okay. Example of the problem is we have like let's say a tank. Okay. We need to cover with the hole. We need to cover. Okay. Involve the M1 and M2. Member one, member two. Okay. And then we are using this kind of code for the bolt. Okay. And then our aim is to know what is the safety factor. Okay. And one of the equation to calculate safety factor is using Goodman. So the equation is something like this: 2xe over something. Right. Last week I covered about C. C is the stiffness constant. Okay, mentioned on page 66. Sorry, 69. KB is referred to the bolt stiffness and KM is referred to member stiffness. And then we have already learned do some calculation together to find the value of KB. All right. All right. Okay. Then for today, we will continue to get the value of Km. The value of Km. Okay. So the equation for Km is on the page. We start on the page 46. We start on the page 46. Okay. Okay, page. I'd like to update on the WhatsApp group. I'm scared that your friend maybe overturn the link. Okay, you mean to, I think it's, I don't know, suddenly many attempt to attend the class, to join the class, okay. In the meantime, you can go through all page 46 regarding these member stiffness. Okay, so the idea is based on the finite element simulation. Okay, where is being model as called as frustum, called as frustum. So if I like to write down, okay, this one. Okay. So the idea is about, it's called frustum, it's more on simulation, finite element simulation. The idea is okay. Okay, the idea is about when we tighten, okay, we can see something like that. The distributions is getting less and less towards distant far from the center. Okay. So therefore, to simplify, okay, we're going to do some calculations based on this fundamental finite element method by getting this kind of shape, triangle, trapezium. So at the end, this kind of shape. That's the idea, theory. Okay, so that's how they come up with this simple shape like that. Trapezium. Sorry, this one should be okay. Trapezium shape. This one should be this one. This one. Okay. If we take this area, this one, green area. Okay, green area. Okay, and then from here, okay, divide this section, and then you have this D, something like that. Okay, so dot, something like that. So this refer to small d. Okay, and then this area is referred to the capital D. Capital D. Capital D. And then this is some angle, different color. Okay, angle. Alright, angle. And Then what else? I think this is T, thickness, thickness. So and then there will be a thickness. Okay. Thickness. Okay. This is the mathematic approach regarding this one. So at the end, okay, by doing some mathematic equation, so okay, for the case in our study, we assume that the this angle sigma is equivalent to 30 degree. Okay, so at the end, if you refer to the page 49, okay, so the equation to calculate the km is become like that. 0.5, 0.5 something. Okay. Over ln something. Okay. That's so. Okay, we can get this equation. Okay, the definition of D, capital D is that area. Uh, Small d is referring to the nominal diameter of the ball. And then we have T. Okay, this one. Okay, D, capital D, D and T. This one you have to know. All right. Then, when we combine all the equation, so finally we can get the equation to calculate the, let's say, okay, that one involve how many members in our case, okay, is reflect to this how many members involved, M1, M2. So therefore, referring to this equation, N1 km is about similar to the spring series. So we have 1 over K1 plus 1 K2 and so on. And so on is referring to the how many members. How many members. Alright, that's a simple explanation. So you have to know, first is the equation, M49, page 49. Okay, and then the definition of all, the meaning of D, small d and T is referring to this trapezium. Referring to this trapezium. I mean, means that is focusing on these, I would say, using this yellow area. Okay, yellow area. Okay, so later we will focus on the example to calculate the member, thruster member. Sorry, stiffness, member stiffness. Okay. Okay, this is our case. This is our case. Okay, I would like to give you step by step, how we're going to calculate the km. How we're going to calculate the km. First step, to calculate km. Step to calculate km. Okay, you get the center line. Get center line. So So first step is get center line. Okay, get the center line. Okay. So referring to our problem, okay, it's good if I redraw again. Okay, so we have washer, and then we have M1. Okay, so we have M1. So step pertama, first step is get center line. So get center line means that is half of a grip length. Half of grip length. For grip length. Okay. So grip length. Okay. So the grip. Okay. So where is the grip length? The grip is between bottom screw and top of the nut. Okay, top of the nut. So therefore, okay, let's say this is our nut. I think I need to write down. Let's say different color, yellow. Okay, so our grip area is between this one. This is our grip area. Okay, or grip area. So grip area, washer thickness. Okay, let's say T washer thickness plus M1 plus M2. Okay, so equivalent to washer thickness. What is the value of our washer thickness last time? Anybody remember?
Uh, 0.065 inch.
0.065.
65 inch.
Okay. Our one is 0.25. Okay, and then plus 0.75. Okay, all right. So we got the. So what's the value?
1.065.
Okay, then we get 1.065 inch. Okay. So the first step asking about center, get center line, half of the grid line. So therefore, our answer here is 0. Apa? 1 kali 2, 16.
0.5325.
53.
25.
Okay, right. Okay, step 1, get center line. Okay. Okay, step number 2, sketch both members area. Okay. We need to sketch both members area. Okay, alright. Okay, so sketch both members area. Okay. Okay, 0. Okay, this is total is 1. Total is 1.065. Okay, sketch both members area. Okay, means that we just want to know the area. Okay, 1.605, our center line. Okay, so this is 0. 0.25, 0.25. Okay, the top is 0. 0.065. So means that select another color, say green. Okay, so means that our center line is somewhere here. Okay, somewhere here. Okay, so this is our center line. Okay, center line 0.5325. Okay, right. Second step is asking you to sketch both members area. Okay, both members area means that get the center line. Sketch both members area. Okay, get the center line, sketch area. Okay, just sketch that. Make something. Let's say it's a green. Okay, just sketch something. Yes, at least we know that where is the center line according to our problem. So it's between member 2. Is in a member 2. Alright, done. After we do some sketch, okay, the third one is, okay, we're going to separate uh, uh, create trapezium, create separate trapezium, separate trapezium. Okay, create separate trapezium. It means that, okay, create separate trapezium according to frustum, according to frustum. According to idea, frustum idea, this one, according to this frustum. Create separate trapezium. Okay, so right. Sketch both members area. Okay. Sketch both member area. Center get center line. Sketch both members area. So in this case, okay, step number 2, I would like to make some clear. Okay, sketch both member area. Okay, means that we're going to do some basic sketch like this. Okay. So from here we can see this is center. So I means that, okay, let's say I create what color? Color. Okay. Okay, means that we're going to create this kind of shape. Okay. So trapezium, sketch both members. Okay. Sketch both members area of trapezium. Okay. So just create this line, just simple, just sketch center to center and then go up. Sorry, okay, from this this washer, just make one simple dot and then just create this one, like this shape. Simple shape, okay. So create separate trapezium. Okay, separate trapezium means that, okay, we can let's say, okay, trapezium means that we're going to separate trapezium. If you can see, this trapezium is referring to this one. So means that simple trapezium, you're going to separate, it's referring to this one. Referring to this, means that this D and this D. Okay. So it's easier. Okay, it's depend. In this case, it's easier for us to start from bottom. So it means that we're going to select trapezium. Okay, start from bottom. Maybe okay. Okay. When we talk about create separate trapezium, you can see there are how many area? There are 1, 2, 3. So means that 1. Okay. Yeah, okay, this is referring to this, maybe this one. Okay, yellow. And then we have another trapezium. What color? Still yellow, maybe green. Sorry, miss up of color. Okay, this one. Yellow, let's see this one, yellow. Okay, yellow, and then next is, let's see this one. Okay, separate. Okay, so we have another this area. Okay, all right, and then the third one, let's say using green. Okay, so separate, create separate trapezium. So sorry for this. So this is going to be the yellow here. Okay, and then the second one will be somewhere here. Okay. Third one is green. This one. Okay. So okay. So first step is get the center. Okay. Second one is sketch both member area. This one. We're going to sketch something to get close to this kind of shape. Okay. And then the third one is we separate the trapezium. Separate the trapezium. Okay. So it means that for easier, okay, for easier means that this is member 1, member 2, thickness, thickness. Okay. Right. So then the last step is get all D1, T1, D2, T2, and D3, D3, and so on. It depends to the how many trapezium. So in our case, there are 3. There are 3. So you need to find the value of if we scarce, we have to find this kind of shape, this kind of value t. So this is going to be number 1. This is number 2. This is number 3. Okay. So T1, T2, T3. Okay, so then find value of D. D is D1. Okay, and then this is D2. And the last one is refer to this shape. Okay, so the D3 should be at the bottom. This guy is this is D3. But to be, I just want to highlight that uh, this this should be a straight line. This is straight line. It means that this one, if I scale, should be same. It means that this one should be somewhere here lah. Should be straight. Okay, so therefore our line should be, to avoid confusing, this line should be straight lah. Should be like that. Okay. Means that it okay. So far clear lah. Sorry lah, means confusing about number 2. So okay. So step 1, get half and then sketch both members. And then step 3, create separate trapezium. And then step number 4, get D1, T1, D2, T2, D3, T3. So okay. Okay. So okay, T3 berapa?
Kosong 0.5325.
Okay. So because this is the center, okay. So 0.535. Okay. Okay, T1 thickness. Thickness is referring to the washer. So this should be similar as 0.065. Okay. So D1, okay, equal to page Okay, so washer is according to page 35. Page 35. Okay. D1 actually is the diameter of washer, diameter washer. So D1 equal to 1.5 times nominal diameter. So it means that 1.5 times D, our screw, 3/8. 3/8. So you get the answer here. Okay. Okay, since this is straight line, so D3 is equal to D1. Okay, D3 equal to D1. Okay, next we're going to find the value of D2 and T2. D2 and T2. Okay. Okay. This is another one. Check here. Okay. Sorry. D2. Okay. D2. All right. See, this is D1. Okay. So from here, this is mathematics. Okay, this is related to the similar to this one. Okay, which is in our case study is 30 degree. Theta is 30 degree. Okay. So then we know this is T1. T1 equal, okay, T1 0.65. Okay. You want to know this area? Z, So Z using sine tangent cos, so tangent O per A, So means that tangent 30 equal to O over A, T1. Okay, so then you can get the value of Z. So what the value of Z? Finally, can get the value of D2 okay, D2 this one, okay, D2 equal, this is D1, D1 plus 2Z, get the value. Okay, try 5-10 minutes, try to do this equation calculation, and let me know if you have any doubt. Okay, 5 minutes. Okay, I think I made a mistake regarding this number of trapezium. Okay.
Ada 4 kan doktor?
Yes.
Trapezium.
Okay. So I repeat again the step. Okay. The first step is get the half center line. Get the center line. Okay. Get the center lines. Okay. So get the center line. We start from this one. We get first step. Get the center line. Means that the grip area. So washer. In our case, washer. M1, M2. Okay. So 1.065. So we get half is 5325. 5325. Okay. Step number 2 is sketch both members area. Okay, this sketch number 2 I think is good referring to this one. Sketch number 2, sketch both members areas. Okay, so I make this simple graph, simple shape like this. Okay. Okay, we create equivalent trapezium by getting the center 5325 just now 53. Okay, 5325. Okay, from 3 area washer M1 M2, then we will get 5325. Okay, center. And then sketch both members areas. So means that sketch both member areas is we getting this shape. Try to sketch means that members member one. Okay, means that start from washer. Washer, this one. Okay, 0.0625. And then it's easier, we draw the bottom M1, so the M2, 0.75, go up. Go up 0.75, which is beyond the center. Okay, next M1 is 0.25. Okay, that's represent the step number 2, sketch both members area. Both member area means that M1, M2. Okay, so I make it clear here. So this is M1, purple, and the green one is M2. This what does it mean of sketch both member area. M1, M2. Okay, the one is create separate trapezium. Okay, so before we create separate trapezium, it's good if we can sketch this. Okay, this one. So means this is yellow. Okay, and then we have a purple. Okay, wait, it's good. Get confusing. I think it's good. Sorry. Purple like just make purple line here. Green, just make green area line here. Okay. All right. So we have a 1, we have 2, green, we have 3, and we have 4. Okay, that's why just now I mentioned about regarding the spring question. Okay, M members M members represent how many trapezium? Okay, how many trapezium? How many trapezium shape? Is that how many trapezium? That is this. This one. How many trapezium shape? We can create after we do this kind of step. Enter, sketch, member, create separate trapezium. So it means that, okay, we have 4 area trapezium. Okay, one. Should I make some separate sketch? So this is going to be 1. Okay, purple here 2. Okay, green here 3. Sorry. And the last one, black. Okay. So this, I think, this is a bit confused. This one. This is a bit clear. Okay, so yellow. Number 1, yellow. Okay. So this is D1. So definitely this is D4. Okay. All right. So D1 equal to 1.5 times nominal diameter of the bolt, 3/8. Okay. So D1 is what the value? 1.5 times 3/8.
0.5625.
Huh?
0.5625.
3 point.
0.5625. Encik 0.5625.
Okay,
Ada 5
okay,
depan.
sorry, 0.5625
Betul.
Okay. So T1 is the thickness, is 0.0625, thickness from the this one, early, okay, from previous, okay. Then, okay, D2, I use purple. D2 somewhere here. Okay. So separate, okay, separate. So this is D2. This is T2. Okay. What is T2? What is T2? From this to T diagram, from this clear diagram, T2 is referring to M1, 0.25, 0.25. Okay, it's very clear. Okay, just a matter of D2. How to find it? Okay, D2 is the fundamental. Okay, D2. If you can see here, this one. This is mathematics. I use red. Red. Okay. Okay. Take this portion, the area. Means that this area. Okay. This area. Okay, we're looking for D2. From here to here. D2 from here to here. Okay. So this shape. Okay. So if I simplify, okay, theta, sigma, sorry. Sigma is always we take 30 degree in our study. 30 degree. Okay, then we're looking for this one. Z prime. They say Z1, Z1. Okay, now we know that this is 0.0625. Okay, 0.0625. So by taking tangent 30 O over A, Z1 over 0.0625, you can get the answer of Z1. Okay, so therefore D2 is equal to D1 here. Okay, D1 plus 2Z1. Z1. This one also Z1. This is mathematics. Okay. Right. Okay. And then you're going to repeat again for D3. D3, say this area. Okay, D3 here. Okay, and then okay. I take this shape. Okay, 3 this one. This 3. Okay, this is mathematic understanding. Okay, D3, and then we know that here is T3. This is T3. Okay, T3 in our case, okay, 0.75 minus, okay, 0.53. Okay, and D3 again is similar to the first one, similar to how we calculate the D2. Okay, so you take this area, okay, this area by changing, let's say, blue color, okay. So this, let's say, this is Z2, okay. So D3 equal to D2 plus 2, eh? So Z2, similar method, so tangent 30 equal to Z2 divide by T2, T2 is 0.25. Then you get T2. So T2 is represent of this area. Okay. This is how we going to calculate value of D3 using D2 information. Okay. Then finally, D4 and T4. Okay. The black one. Okay. The black, this one. Okay. So, but we need to rotate so that the shape is similar to the idea of frustum. D4, D4. Okay, so from here we know that D4 is 0.5, half, half D5, 3 to 5. And our D4 equivalent to D1. Okay. So that's how we get the value. Okay, so Sorry, fatigue my hand. I use a different mouse. It's very slow. Okay, so I repeat again. Okay, step number 1, get center line. Okay, step number 2, sketch both member area. And then create number 3, create separate trapezium. From here you have to define how many. Create separate, maybe I put here some unknown and trapezium. So this until you find the end. So just now by and get more that is the how many trapezium you able to get by separate. So that's written get the center 0.5, and then number 2 sketch both member area, so means that get the equivalent trapezium, and then sketch member area means that where is your your M1, where is your M2. So M2 is 0.75, the thickness will be higher than center line. So then you create separate. So this is by getting separate, so you have this is of your washer, M1. So 3 and 4 actually is the involve your M2. And all those value. So the next step is, I hope you're able to continue. I hope you're able to follow. If not, you just write down step by step during this class. Maybe just today I focus how to get the KM. Very not confusing, but it's very need to clear understand. Definitely during your test 3 you need to find this C. So this is the step. So finally your equation to find the Km will be 1 over K1. So remember you have 4 K2 plus 1 over K3 and 1 over K4. Okay. So the differential equation to find Km is stated on page 49. So 0.577 for y ED over ln. Okay. Over ln. Okay, the issue here is the value of E. The value of E. Tidur lah bertabah lah. Okay. E1, number one. Okay, number one is referring to E. Say I write down here E. K1 is the washer. So let's say, okay, normally washer is using steel. So E is using steel modulus yang. Okay. K2 is referring to the your number 2. In this case, number 2 is referring to M1. So you have to know what's the material for M1. Okay, to be given. Let's say maybe K2, maybe it's not steel. Depend. Normally it's given. So you have to know. Let's say the X material. So you have to know what is the value of X material. Okay. So K3. That's very important. Our sketch here. Okay, K3 is the material of M2. KT is the material of M2. So okay, this one should be either M1. K2 material of M1. K3, if you refer to your sketch, 3 is yang is referring to M. And we have another last K4. Definitely K4 on here. So is of M2. If M2 is very of the value of the modulus yang. Okay, so finally you get the value of Km here lah. Okay, and then by substitute the value, so finally without value you can get the Kb plus Km, value of C. Okay. Okay, so that's all our lectures today, just to find the value of Km. The value of Km. Any question?
No, doctor. Okay. But
is it clear my explanation on how to find the Km, or confusing?
okay, doctor. A bit clear. Maybe I have to see another time.
Okay. For attendance, I assume everybody's coming. Consider maybe some of your friends involved in the flood. Okay. Just now, okay. Before I leave, we stop the class. Okay, those wish to have I have maybe half an hour at least. I will continue to have a group discussion as wished by I don't know, forgot, S3 KOC. Is it? Is it K3? S3 KO5, I think. Okay. All right. So, okay. Before we end the class, around the table, any question?
Doctor, is that my group also can join, Doctor, for the group discussion? Because
No
we
problem.
finished already
If,
about the gap analysis.
if I have another time, maybe maximum 3 group, maybe beside group S3 KO5. Yeah, you can stay if you have any time. If I have extra time, and then we can continue to discussion. Okay, the rest,
Okay.
thank you for coming. See you again next week for the last, maybe last lectures for the subject focusing on chapter non-permanent joint, chapter 10, chapter 8, forgot. Chapter 8, I think. Chapter 8, yes, okay. All right, thank you, Kamil. See you again. No need to update the attendance on